Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website arifpad.me. The other way is to download the notebook file from course GitHub account arifpucit. And all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture 7.2 of the 7th module, Overview of Natural Language Processing, for the course titled Tools and Techniques for Data Science. The title for today's session is Basic Text Preprocessing. My dear students, this is our second session on overview of NLP. And by now, we know that NLP actually encompasses all the tools and techniques that enable computers to understand and generate human languages in both written and verbal form. Well, in the last session, we discussed what is natural language processing and the challenges or ambiguities that we are going to face. We try to understand the morphological, lexical, syntactic, semantic, and pragmatic analysis, as well as disclosure integration with example sentences. Then we talked about different real-world applications of NLP, which can be broadly classified into 5 categories: sentiment analysis, information retrieval, information extraction, machine translation, and question answering system. We also discussed at an abstract level the 3 approaches that one can use to solve NLP problems, namely the heuristic approach, the machine learning approach, and the deep learning approach. And finally, we tried to understand the NLP pipeline and its different phases. About the first phase of data acquisition, I have already uploaded 4 video sessions. So today we will start with the second phase, that is text pre-processing, which I have further divided into 3 parts: text cleaning, basic pre-processing, and advanced pre-processing. Let us move on to the agenda of today's session. My dear students, whether you are dealing with numeric or textual data, the cleaning of this data is the most time-consuming as well as unenjoyable task. Having said that, this is the most important task as well of any machine learning, deep learning, and NLP application. Remember, garbage in, garbage out. That is, feeding dirty data into a great model will give you results that are meaningless. When dealing with numeric data, data cleaning often involves steps like removing null values, removing duplicate data, dealing with outliers, and so on. On the contrary, when dealing with textual data, data cleaning is referred to as text pre-processing. For the ease of understanding, I have divided the text pre-processing into 3 steps. First is the text cleaning, in which we will learn as how we can remove unnecessary digits, spaces, new line characters, HTML tags, URLs, and punctuations. Second is the basic text pre-processing, in which we will learn to do the case folding, expanding contractions, handle the chat word and emojis, do the spelling corrections, understand the need of tokenization, n-grams, and stopword removal. My dear students, the third part, advanced pre-processing, will be dealt in the next session, inshallah, where we will cover stemming, lemmatization, parts of speech tagging, and named entity recognition. At the end of today's session, we will load an airline tweets dataset from a CSV file in a pandas data frame and perform text cleaning and all these basic pre-processing tasks that we have learned today on around 50,000 tweets of that dataset. So we have a lot to do today. So let's start playing. Well, my dear students, in order to perform different text pre-processing tasks, we will be using libraries like NLTK, spaCy, gensim, textblob, contractions, and so on. So let me install these libraries first. Don't worry, as we progress in our sessions, we will keep exploring different functions of these libraries as per the need or requirement. So this is done. So let us start with the text cleaning part. My dear students, at times you don't want digits to be part of your textual data. For this and many other such string processing tasks, one can use regular expressions. In Python, we have a built-in re module that supports splitting, pattern matching, and string substitution. In simple words, a regular expression is a sequence of characters that specifies a search pattern in a longer piece of text. And this search pattern is created using meta characters, quantifiers, and escape codes. In the domain of NLP, one must have a good understanding of using regular expression. And those of you who are new to regular expression can watch my two videos on this topic available at these links. In today's session, we will be using this substitute method of a Python RE module, which is passed three arguments. First is the pattern that we want to search. Second is the replacement string. And third is the source string in which we want to perform the replacement. Well, the actual task is to create the pattern, which is the first argument. And let us understand this with this example. Well, this is a string from which we want to remove all the digits. We are using the re.sub method, and since we just want to remove the digits, so the second argument is an empty string. Note the regular expression or the pattern, which is the first argument, having escape codes and quantifiers. This \w is the escape code that is used to match alphanumeric characters. This asterisk is the quantifier saying that the previous expression can be repeated 0 or more times. This \d is once again an escape code for digits 0 to 9. So when we will execute code of this cell, the function will return a new string after removing digits and words containing digits from this source string. Let me execute it. Great. So all the digits and digits within alphabetical characters have been removed. Let's move ahead. My dear students, at times your textual data contain extra spaces, or maybe while removing digits or other unrequired characters, more than one space is left in between the text. And suppose this is a text that is having unnecessary spaces in between, and we want to remove them. And this is a simple code that use re.sub method. The pattern argument over here is this, a space followed by a quantifier plus, which means search for one or more spaces. The replacement string is a single space. Simple. Let me execute it. Great. All the extra spaces have been replaced by a single space. And similarly, this piece of code is actually replacing the new line character with a space. I hope this is making sense to you all. I've just made toy examples to make you understand all these pre-processing tasks. Well, my dear students, if you have scraped websites for data acquisition, your data may contain unnecessary HTML tags. And once again, this re dot sub method comes for your rescue. Note this pattern over here. The period over here means single occurrence of any character except new line. Well, the asterisk means the preceding character or expression is repeated 0 or more times. And this question mark means 0 or 1 occurrence. I've used to make it non-greedy. Anyways, in simple words, this regular expression will select everything that is there inside the angle brackets, including the angle brackets themselves. And of course, all such occurrences will be substituted by an empty string. So this is a sample string on which I am applying this substitute method. And you see the pre-processed string has no HTML tags. Great. Let's move ahead. Okay, removing of URLs. Suppose we want to do a sentiment analysis on our data which contains URLs which might not be helpful in classifying the sentiment of the text. So you need to remove the URLs from your data set. And this is the regular expression or the pattern. May seems a bit tricky to you. If you have not watched my YouTube video lecture 2.18 on regular expression, let me try describing this. Okay, so this question mark after the S means that this S is optional. It can be HTTP or HTTPS. This colon double slash will be there. This backslash S plus, this is a escape code, but before that, this or symbol, this straight line, uh, uh, this says that this will match any string on its left or right. And on the left of this straight line, we have backslash S, which is an escape code used to match any non-white space character. And the plus symbol is a quantifier meaning one or more. On the right of this straight line, we have this dot. In simple words, this regular expression will locate a URL whether it has a or not. Then we have a period followed by one or more non-white spaces characters, and it will be replaced with an empty string. Okay, let me execute it. And great. You see this URL is no more part of our string or text. Okay, my dear students, in English language, punctuations are symbols that are used to divide written words into sentences and clauses. While tokenizing your text, the punctuation symbols may become part of a token or may become a token by themselves. And most of the time, this is not required. The Python built-in string module contains some constants like string punctuations. Let me show them to you. So there are roughly 32 English punctuation symbols. Let us use these to remove punctuation symbols from our text, which is this. We can remove the punctuations by iterating this string character by character. This can be done using a loop, but over here I am doing this in the Pythonic style. And this is the Pythonic style. A list comprehension. Which is a concise way to create a new sequence based on the values of an existing sequence. Well, note this code inside the straight brackets having four elements. Well, this is the expression. Then we have for item, that is ch uh, in this iterable, and if this condition is true, so this will return a list, and the join method over here, when called on empty string, joins the characters of the newly generated list to a single string. My dear students, if you are not comfortable with list comprehension, once again you can watch the introductory video of mine on basic Python programming. But anyway, this list comprehension has actually iterated over all these punctuations, and if any of the character is not part of this, only then it has generated the new string. Okay, so we are done with the text cleaning, in which we have learned to remove digits, extra spaces, HTML tags, URLs, and punctuations. Let us move ahead and see some basic text pre-processing tasks. And the first is the case folding. My dear friends, the text we need to process may come in lower, upper, sentence, or maybe camel case. If the text is in the same case, it is easy for a machine to interpret the words, because the, the lower and uppercase alphabets are treated differently by a machine. Well, the easiest way to do this is use the lower method of the Python built-in string class. Let me execute this code. My dear students, this can also be done by iterating over all the characters of this string, and if the ASCII code of an alphabet is between 97 and 122, simply subtract 32 from it. Anyways, using this lower method is more simple and quick, I think. Okay, my dear students, contractions. Contractions are words or combination of words that are shorthand, uh, that are rather shortened by dropping letters and by replacing them with an apostrophe. These are the few examples. Uh, you can see, instead of writing U space R, we normally write U apostrophe RE, and this ain't instead of am not, are not, is not, has not, and so on. You can Google for more such examples. Well, in order to expand contractions, you can use Python contraction module. And we have a method fix. We have a fixed method of the contraction module that can be used to expand these contractions. Let me execute the code of this cell. This is self-explanatory. Okay, now consider this string containing contractions like uh, I will, and should not, I would, it is, and we have. Let me expand the contractions of this string. So this is the string. Over here I am using a loop, as you can see, to iterate over all the words of my string. Note that I am using the split method, that is splitting my string into a list of strings at every occurrence of space character. And inside the loop I am passing every word to the fix method and appending the word to a new list. And after the loop I am calling the join method on space and passing it the new list, and this will return a new string of words. Great. All contractions of this string have been expanded. You see this, instead of this I'll, we have I will, and Instead of having shouldn't, we have should not. Great. And over here, I am repeating the task using the list comprehension. Note the code inside this straight bracket once again, having three elements this time. And this is the expression for item in this iterable. So I want to do for every item in this iterable, I want to perform this task. Great. So expression over here is the result of calling the fixed method on every item which is a word inside my string. Well, this list comprehension will, as usual, return a list of expanded words, uh, and once again, on which I am calling the join method to join these expanded words with a space character in between. Note that there is no difference between the two outputs. However, list comprehension is a smart and elegant way of doing such tasks. Let's move ahead. My dear students, these days we all communicate with each other using short messaging service on our mobile phones or may use social media apps like Facebook, WhatsApp, Twitter, Instagram, and LinkedIn. And while communicating on social media websites with friends and colleagues, we use abbreviations and shorthand form of words. Some commonly used are GN for good night, ASAP for as soon as possible, and so on. And these are not standard English words. So before performing some NLP tasks on such textual data, we need to treat these chat words or abbreviations. Okay, let us use our dictionary for this task. You can search for available online dictionaries, but over here I am using a small dictionary of my own having key value pairs, where keys are the abbreviations and values are the corresponding expanded words. Okay, consider this a string. So this is a string having uh, this abbreviation OMG for oh my god and BA5 for BA5 is for what is this? That this is back in 5 minutes. And here is the code that use above dictionary dict chat words to expand the chat abbreviations. Well, over here I'm using the split method to split the sample string into token words and using this for loop, I'm iterating over each word. And if the word is in the dictionary keys, we append the corresponding dictionary value in my list. Otherwise, we simply append the word. And after the loop, over here, we simply join the words in my list on spaces. Let me execute this code. And it says dict chat words is not defined. Dict chat words, of course, is not defined. And now it is done. Note all the chat words are expanded as per our dictionary. So this OMG has been expanded to oh my god, and this BA5 has been expanded to back in 5 minutes. Okay, so what next? We have emojis now. My dear students, we come across lots and lots of emojis while scraping comments from social media websites. Uh, well, according to Wikipedia, emoji is a combination of two Japanese words. E means picture and moji mean character. Anyways, while pre-processing of text containing emojis, we can simply remove the emojis from the text data if our application logic doesn't require them. Consider this string having lots and lots of emoji symbols, just created to let you know that we can always remove them. One way to remove them from text is to use a regular expression, and here is the list of code ranges for different emoji symbols. I've taken this from the net. You can compile the string using the re.compile method, and then call the substitute method on this pattern object. I have called the substitute method on this pattern, emoji underscore pattern, which I have created over here. Let me execute this, and you see these emojis have been removed. My dear students, instead of removing the emojis, you may like to replace emojis with their meanings. And an easy way to do this is to install the emoji module, and it has a method demojize, which replace Unicode emoji in a string with emoji shortcodes. So let me call the demojize method of emoji module, which I have already installed, and let me pass this string to it. Okay, so this says emoji is not defined. Of course it is not. Let me import it. And you see this thumbs up emoji has been replaced by its Unicode. Let me execute this. You see this thinking face has actually been replaced with this thinking face. And of course you can use the replace underscore emoji method to replace an emoji with an empty or maybe appropriate string of your choice, as I have done this over here. I hope this makes sense. Excuse me. My dear students, if your data contains spelling errors and you proceed without correcting them, then a single word might get represented in more than one ways, thus affecting your final result. You might have observed while typing in editors like Microsoft Word or while writing your email that the incorrectly typed words get underlined, and the editor might do an auto correction or may suggest you a list of possible correct words. That means these applications perform spelling detection as well as correction using some algorithms behind the curtain. And before we understand how spelling corrections are done, let me tell you that there are two main categories of spelling errors as shown over here. First is the non-word errors. My dear students, non-word errors are non-dictionary words. For example, instead of uh, typing reading reading, the user has typed reeding reading, which is not a dictionary word. My dear students, these non-words are easy to detect by a simple lookup of a word for its non-existence in the language dictionary. And for correction of non-word errors, you can generate a set of candidate words which are similar to the erroneous words using algorithms like shortest weighted edit distance or maybe highest noisy channel probability. Well, the second category of errors as shown over here are the real word errors. For example, instead of typing great, GREAT, the user has mistyped greet, GREET. And these are called typographical errors. And instead of typing maybe TWO2, the user typed TOO, which are called cognitive errors. But dear students, the real word errors are difficult to detect as the incorrect words are also part of the language dictionary. Please stop this video and try locating non-word and real word errors in this sentence. Detailed discussion on the detection and correction algorithms is beyond the scope of today's session. So let's move ahead and see the usage of this text blob library. for the detection and correction of errors in our textual data. And let me install this library, import and check its version. It is 0.17.1. Now let me import a text blob constructor from a text blob and pass it the string to create a text blob object. Let us now see different attributes and methods of this blob object using the dir function. So we have lot many over here, and we are interested in this correct method. So over here in this line, I am passing this string to the correct method of blob to perform spelling correction and returning me a string. So let's see. Note that this R-E-E-D-I-N-G has been corrected to R-E-A-D-I-N-G. Do note that it has detected and corrected all the non-word errors but has failed to detect the real word errors. So we still have this GREET, greet, and this CURSC, curse, instead of course in the corrected string. Okay, let me quickly make you understand how text blob actually do this. Well, the words attribute of blob object returns you the list of words in the text or string passed to it. So this is the list of words, and let me use the spell check method on the mistyped word, this REEDING reading, which is at index 2. Let me use spell check on this. It returns a list of tuples having the candidate words with a confidence value. So it is suggesting to replace the mistyped word REEDING with READING with a confidence value of 0.765. Similarly, over here I am running the spell check method on the erroneous word BOOK, book. Let me execute it. And it suggests that replace it with the dictionary word BOOK, book, with a confidence value of 0.946. And finally, if you run a spell check on the real word error greet, it says that this is a dictionary word and there is no need to correct it. So you have a confidence value of 1.0 on this. My dear friends, even with this limitation of text blob, that is, it cannot correct real world errors, it can successfully detect and correct 70% of the spelling errors in your text. Okay, I think enough for spelling correction. Let's move ahead. Okay, my dear friends, here comes the most important step of pre-processing, and that is tokenization of text, which is the process of splitting text into meaningful segments called tokens. Well, tokenization can be performed at character level, subword level, word level, and also the word level is called unigrams. We can do tokenization at two word levels, also called bigrams, and so on. And we can, of course, perform tokenization on sentence level or maybe even at paragraph level. The level of tokenization you need to do, of course, depends on the problem you are solving. And a question that might come to your mind is, why on God's earth we need to tokenize our text? My dear friends, suppose you want to classify a tweet or a product review as positive or negative using our dictionary of positive words and negative words. So you will simply tokenize your text into words and check if the count of positive words is greater than the count of negative words. If yes, you will say it is a positive review. If not, you will say it is a negative review. Now the question is how to tokenize. After answering the what and why part, we need to answer the third question, that is what. My dear friends, the simplest way to tokenize your text into words or unigrams is based on spaces. While tokenizing text, you come across some challenges, and that is due to these four components that you may come across in your text, that is prefix, suffix, infix, and exception. And there are different ways to deal with them. Let's understand them first. Let me talk about prefix first. My difference, prefix is a character or characters that comes in the beginning of a word. Some example of prefixes are opening brackets, quotes, currency symbol, and salutations like Mr., Miss, Doctor, etc. So we will always like to separate the amount of currency from the symbol of currency. Then we have suffix. You may come across suffixes as well, like kilometer after the distance digits, a comma or a period, maybe a sign of exclamation or a closing bracket or quote. Over here, we will like to separate the distance value from its unit, that is kilometer. The third is infix. Infix are characters that comes in between words. For example, the word cooperate may have a hyphen in between. Similarly, hyphen or a forward slash may appear between dates. You might have seen different formats of dates. Finally, we have exception uh, or special rules. For example, in case of L dot A dot exclamation, the exclamation mark is separated while L and A are not separated, and this is what is required because L dot A is Los Angeles, and we will like to keep it as a single token. Okay, so far so good. Now that we know the challenges that we may come across while tokenizing our text, let us now see some very basic and some sophisticated ways that we can use to tokenize our text. And the simplest way is to call the split method on your text and specify the separator. Uh, well, of course, on this text, the split method works fine. But on this text, this example is great, sign of exclamation. The sign of exclamation has become a part of this token over here. So later this token will not match with the word great. So this is the problem that we may come across later. My dear friends, we can use the split method of the Python RE module as well. We just compile the regular expression, and this backslash W is an escape code that matches non-alphanumeric characters. The plus symbol is a quantifier, meaning one or more. So we are splitting this string on occurrence of any non-alphanumeric character. Let me execute this. Great. Note that this time the sign of exclamation is not part of the token great. However, this symbol is not there as a token. What if I need it? Another limitation of using regular expression for tokenization is that we may need to write complex regular expressions for different scenarios. So a good option is to use libraries like NLTK, spaCy, TextBlob, and GenSim for tokenizing our text. Let's start with NLTK. My dear friends, a natural language toolkit is a suite of string processing libraries that is heavily used while performing NLP tasks. Uh, just install it if you have not done before. Let me import it and check the version 3.6.5. And let me tokenize the string. This example is great with a sign of exclamation. And this time I'm using the word underscore a tokenize method of NLTK tokenize module. Let me execute it. Good. You see, this time we have the exclamation symbol as a separate token. Let's try tokenizing this string. You should do your PhD in AI, sign of exclamation. Great. Let me try this now. Oops. We have issues. Uh, Note the contraction should have. This has been separated as two tokens, but it has been separated something like this, which is probably not required. Moreover, uh, the email address arif at pucit.edu.pk has not been tokenized as a single token. Rather, Arif is separate, at is separate, and this portion is separate. And similarly, this URL is also not properly tokenized. And here is another example of word tokenize. And this method has successfully separated the currency symbol from the currency amount. You see, currency symbol and currency amount, but has not been able to separate the distance from the unit. So this is as one unit. So NLTK word tokenize method has its own limitation. Let's move ahead and see uh, another library, spaCy, that is used extensively in the industry. My dear friends, spaCy is an open source NLP library designed to handle NLP tasks with the most efficient and state of the art algorithms and is released in 2015. Well, spaCy supports many different languages like English, French, and German, but before using it, you have to download and then load the language model for the language you want to work on. So let me first install spaCy. Oops. And check out its version. So it is taking a bit of time. 3.4.1. Now let us download the pre-trained spaCy model for the English language. And the name of the model is 1, 2, 3, 4. It consists of 4 components. Well, this EN is for English. This core specifies the type. A core is the model type that you can use for parsing, tagging, lemmatization, and named entity recognition. This third component is genre, and it can be a news or a web, representing the dataset on which this model is trained. And the last SM, the fourth component, this is the size, SM for small. You can have MD for medium, LG for large, and TRF for transformer. To save time, I have just downloaded the small one. Once again, this may take a little bit of time. After we have downloaded this, you can of course use this model to do the tokenizing and many other such tasks. So it is done. Great. Uh, so let's do tokenization using spaCy. Uh, it is a two-step process. First, you need to import spaCy and load the appropriate language model to variables, say NLP. Then you have to convert your input string to a document object by passing the text to the NLP method. Let me execute this. You see spaCy has correctly tokenized the distance symbol as well, which NLTK failed to tokenize. Let's execute this example containing email as well as the URL. So this email arif at pucit.edu.pk has successfully been tokenized by spaCy correctly, which NLTK of course failed to do so. However, spaCy also failed to tokenize the URL as a single token. So my dear students, there is no single best solution. You need to understand your data and the problem at hand and then tokenize. However, so far I think spaCy is the best to tokenize. Um, my dear students, the spaCy doc object has many other associated attributes as shown over here in this table, and these we will inshallah discuss and explore in our next session. Okay, so after tokenization, let me touch upon the concept of n-grams as well. Uh, so first question that might come to your mind while talking about n-grams is, what are n-grams? My dear students, n-gram is a sequence of n words. You can have a bigram, which is a sequence of 2 words, a trigram, which is a sequence of 3 words, and so on. The next question is uh, the why, naturally. Why do we need to create a bi or trigram instead of unigrams, which we have done above? My dear students, the intuition behind creating tokens of more than one words is that they can capture contextual information compared to just unigrams. For example, the bigram good food carries more meaning than just good and food when observed independently. The application of n-grams is there in sentence completion as seen in Gmail, spelling and grammar correction as seen in Grammarly. Another question that might come to your mind is what is the perfect value of n? Let me say that there is no simple answer, as different values of n-grams are suitable for different types of applications. For example, research has shown that trigrams work better if you are doing a spam or email classification. So after understanding what and why, let us now see how to create n-grams. Okay, so you can do it programmatically or can use a library of your choice. For the time being, let me use NLTK again. Over here, I am using the bigrams method of NLTK and passing it the tokens of the input string. This is the input string. First, I have tokenized it using word underscore tokenize method, and then I have passed these tokens to the bigram method of NLTK. And later we can iterate through it to print bigrams as shown over here. Great. Uh, Note the window is of one word and the total number of bigrams are 10, which is equal to the number of tokens in the document minus the value of value of n plus 1. So these are 10, and this formula is shown over here. Note that Allama Iqbal was are. So the window is always of a single word. Great. Uh, my dear students, you can create trigrams as well. You can use the trigram method of NLTK. You see, you have now trigrams. Lama Iqbal was are, and so on. And you can also use the n-grams method of NLTK by passing it two arguments, the list of tokens and the value of n, which is I have kept 3 over here. So you see this is same output as over here. We can have 4 over here. So now we have tokens of 4. I think now we all have a fair idea of n-grams after understanding and answering the three questions: what, why, and how. Let us move ahead and see what is next. Okay, so far so good. My dear students, every language has its own set of stop words, which are extremely common words having very little meanings. And some English stop words are the, a, and, was, were, at, will, on, and so on. Whether you should remove stop words from your textual data or not depends on the problem you are working on. Uh, I think you should remove stop words if you are working on problems like text classification, caption generation, and auto tag generation. This will decrease the dataset size and time to train the model will also decrease. And my dear students, I think you should avoid removing stop words from the text if you are working on problems like machine translation, language modeling, text summarization, and chatbots or maybe question answering problems. Let us remove stop words using NLTK. My dear students, we have already installed NLTK base library. However, to download and install different packages and corpora, you can use the download method of NLTK by passing it the required package. So over here, I am passing it the package stopwords. If you do not pass anything over here, it will open a window and will let you select different packages. So it is done. Okay, now let me import the stopword module from nltk.corpus, and in order to view the stopwords of a language, you can use the uh, words method by passing it the language. Let me execute this. So these are the stopwords of English. I think 179 stopwords. Let me check out the stopwords of Arabic. So these are the stopwords of Arabic. Let me check out for Urdu. So unfortunately, we do not have stopwords for Urdu in NLTK. You can always contribute for this. Anyway, okay. Now over here, I have written a function to remove the stopwords from the text passed to it, and it returns the updated string. The logic is very simple. You simply split your text into words and then iterate on each word. If a word is not in the stopword list of the English language, you append it to a new list. And finally, over here, I've used the join method to create and return a new string of the words in the new list. Consider this email text. Your Google account has been compromised. Your account will be closed. Immediately check this link to update your account. And let me call this function on this text, which will remove the stopwords from this text of this particular email, which seems to be spam to me. Let me first execute this function. Note the resulting string has all the required and important words that will still classify this email as spam. Google account compromised, your account closed, immediately click link, update account. After removing the stop words, uh, if we pass this resulting string to the model, it will, I think it will classify it as spam. Let's see another example. Let me run this sample string, pass this to this function, and let's see what is the output. If you observe the output, my dear students, after removing the stop word is and not, the new string has become this movie good, which has changed the overall sentiment of the sentence from negative to positive. So it is better not to remove stop words if you are working on sentiment analysis problem, or maybe you need to handle the negations before you remove stop words. Okay. Uh, uh, my dear students, the way we can remove stopwords using NLTK, the same can be done using spaCy as well. We have already installed spaCy, and we have already downloaded the pre-trained spaCy model for English language, and I have imported it. To view the stopwords in spaCy, let me execute the code of this cell. So there are 326 stopwords in spaCy. Uh, my dear students, using the same logic as discussed above, this function removes the stopwords from the text passed to it using spaCy this time. Now consider this string. This is a sample text and we need to remove stopwords from it. And let me use this time spaCy to remove the stopwords. Great. I hope this makes sense. My difference in spaCy, you can add a stopword to the default set. Uh, Over here, I'm adding AKA to the set of default words. It is a two-step process. First you just add, use the add method, and then uh, uh, you set the stopwords tag to true. You set the appropriate tag to true. So this is what you need to do for every word. Let me do this. Now let me check out whether uh, this word is there or not. It is true. And let me check out the length. Simply check out the length. So it has become 327. So that means this AKA is part of this now. And if I run the code of this cell now, so this will give you 327, and you can find out AKA somewhere over here. Anyway, the way you can add stopwords to the existing list of spaCy, you can remove the stopwords as well. So you can always do this, and this is I think quite simple. You can see once again we have 326 stopwords. That is, AK is now no more part of the default stopwords of spaCy. Great. My dear friends, before closing the session, let me show you as how we can perform all these text cleaning and basic text pre-processing tasks on a real-world dataset. Well, you can download this dataset from Kaggle. Let me click this link. We have a tab over here. This is already opened. Internet Movie Database. This is an online information related to films, television series, and streaming contents. And this particular dataset has 50,000 movie reviews, and each is annotated or labeled and classified as positive or negative. Please download it and let me fall back to the notebook. Well, I have already downloaded the dataset. Let me use Panda's read CSV method and load the file contents in our data frame. So we have the review column and a corresponding sentiment column. Let me use the info method on this data frame to get some information about the data. So this data set has uh, 50,000 entries, and none of the entry in any of the two columns is null. You can see this. Let me check the counts of positive and negative reviews. So there are 25k positive reviews and 25k negative reviews. This seems great. A perfectly balanced data set, since we have equal number of positive and negative reviews, and this can be seen graphically as well. I have used the cat plot method of Seaborn, and the kind of plot I have mentioned is count. This also shows that we have equal number of positive and negative reviews. Well, my dear students, for carrying out pre-processing on 50,000 records will take a bit of time. Mm. So to save time of this video, let me take the first 1000 records only for doing these pre-processing tasks. For this, I am using the iLock method. The first argument to iLock is selecting the rows from 0 to 1000. 1000 is not inclusive. The second argument is simply a column, which means select all the columns. So let me execute this. Now this temp underscore df is a new data frame having just 1000 records. Great. Uh, let's check out again if this data set of 1000 records has equal number of positive and negative reviews. It is balanced or not. Sort of 1K reviews, there are 501 positive reviews and 499 negative reviews. I think it's okay, it's balanced. Let me save it, save this data frame to a file using the toCSV method, and the file name is imd dataset -1000.csv. Great. Okay, so let me load this dataset, this new dataset having just 1000 records, the review column and the sentiment column. So here is the actual first review. If you want to see that, over here you cannot see it completely. This is the first review. You can see there are tags, HTML tags over here, which we need to remove. There are double quotes and so on. Okay, so here is the user defined function that is text cleaning, and uh, it is doing the case folding. It is removing the digits, replacing newline characters with space, removing HTML tags, URLs, removing punctuation. This is expanding corrections, contractions, and all these tasks have been discussed above. Okay, now let me call the apply method on the review column of the data frame, and it can be passed, this apply method can be passed to three arguments: a function, the axis, and the arguments. But over here I'm passing it a single argument, which is a lambda function. In simple words, this x is a specific review, and it will be passed to the text cleaning function, and this will happen for all the text under the review column of the data frame. Or in more simple words, this apply method will apply this text cleaning function to all the 1000 reviews. Let me execute it. Okay, so we have applied it, and I have created a new column in the data frame with the name of r underscore cleaned. So this data frame is the cleaned data frame. You can see, if you see the second review, over here we do not have this HTML tag. So I've just kept this new column over here so that you can easily compare them. Okay, my dear students, similarly, on the same pattern, over here I'm applying the word underscore tokenize method of NLTK on the text under r underscore cleaned column. And I've saved it in this new column r underscore tokenized. So this is a new column. I have converted the string under this column into proper tokens. And let me remove stopwords. Similarly, the code of this cell is removing the stopwords. Let me execute. So the stopwords are removed. I have used this function. The logic has been discussed on toy examples throughout this video. I hope this is making sense. The only difference is I'm using the apply method on the appropriate column of the data frame, and this is the new column, and this over here does not contain the stopwords. You can see in this first record we have of and the, while of and the has been removed from the r underscore tokenized column, and under this column you do not have the stopwords. Great. I hope this is making sense. Uh, okay, finally, what I'm doing over here is I'm just saving it in in a new CSV file. But before I save it, my dear students, remember that you do, need not to perform all the pre-processing steps that we have learned today on your dataset. And what all pre-processing steps you perform depends on the type of the text you have in your corpus and the problem at hand. So over here, I'm saving this new data in a new CSV file. The first line of code over here is applying the uh, join method on all the tokens of every review under the r underscore no underscore stopword column of data frame and saving it in a new column titled processed reviews. And this second line is actually creating a new data frame by concatenating just the two columns, and that is the sentiment and the processed reviews column. And finally, I'm saving it and showing it to you. So now we have the sentiment and we have the processed reviews. Great, great job done. Okay, so that is all for today's session, my dear students. I hope the session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.